Okay, this is a example problem for you guys. It uses two triangles, looks more complicated than the other examples, and should help you solve 4 to 5 problems from the worksheet I gave you. So what is this problem? We have a electric pole that is 10 meters tall, and it is sitting, it's into the ground, and then it is held in place by two guy wires, A and B. And those guy wires make 35 degrees and 45 degrees to the ground. And we are interested in the length of these guy wires. We are also interested in finding the distance between the guy wires. So what you should notice here is that we have a small triangle, triangle ADC, and then we have a big triangle ADB. So we have two right angle triangles, which means we can use both the right angle triangles for finding the A and the B. So to find the A, we need to first identify which triangle we are working with. So in triangle ABD, that's a larger triangle, the A is the hypotenuse and the 10 is the opposite side to this angle. And we know from SOHCAHTOA, opposite and hypotenuse, we have to use sine. So we go sine 35 equals opposite over the hypotenuse, which is the side A. And we realize that the unknown is in the bottom here. So one easy technique for you to remember when it's an unknown is you can switch these two because the A is dividing on one side. When it goes to the other side, it will go to the numerator from the denominator here. Here, the sine 35 is on top because you can pretend that this is a fraction. So the sine 35 is going here to the bottom. So it will look like this, 10 over sine 35. Now I have ignored the 1 here because anything divided by 1 is just simply 1. I put this into my calculator and I found the answer to be 17.4 meters. We can do a similar calculation in triangle ACD. I can find now the hypotenuse, which is B, as sine 45. Again, the same opposite and hypotenuse, So we use B over 10. And again, we can do this switcheroo. And so what we have is, oh, I'm so sorry. I made a mistake here. So let me get rid of that first. Okay. So here it is not, it is 10 over B. And when we switch here, B equals 10 over sine 45. And when I put that into my calculator, I get 14.1. So we have solved for both A and B. That was simple enough. Now, when it comes to solving for x, we need to think a little bit here. So, the x is part of this triangle ACB, and this is not a right angle triangle, which means the SOHCAHTOA will not work. We need to do a indirect, we need to follow a indirect method to find the value of x. So my plan is, if we can find the side DB, because that is part of a right angle triangle, we can use SOHCAHTOA. And if we can find the side DC, if I subtract the two, I can find the value of x. So what I'm saying here is, if I can find the value of DB, because it's a right angle, it's part of a right angle triangle, and if I can find the value of DC, again part of a right angle triangle, I can subtract the two and I can get the answer. So let's get DB. In triangle ABD, I'm looking for DB, and the DB here is the adjacent side, and we have the 10, which is the opposite side. So adjacent, opposite, we can use tan. So using tan 35 equals opposite side over the adjacent side. Notice here, the unknown is at the denominator, which is the same thing as the first case, which is the same thing as the second case. So let's do the flipperoo here. So we get dB equals 10 over tan 35. And I found dB as 14.3 meters. Oh, I'm missing a meter sign here. Meters. And so I can now go ahead and calculate the DC from the triangle in triangle ADC. If you look at the triangle ADC, this is the angle, the DC is the adjacent side, and AD is the hypotenuse. Again, we are going to use tan. So using tan, we have tan 45 equals 10 over DC. I'm going to follow the exact same steps. So I'm going to skip to the answer, which is 10 meters. So X equals 14.3 minus 10, which is 4.3 meters. There are about 4 problems, I believe, in the worksheet, which require you to solve it in the exact same way. Okay. All right, hopefully this was helpful, and see you later in another video.